Unit 1, Summative Assessment, Ratios and Proportions. Number 1, write a ratio in simplest form for the following description. There are 18 girls and 6 boys in a classroom. So we're going to set up the ratio of 18 girls to 6 boys, and then make that into a ratio in simplest form. So I'm going to actually rewrite this as 18 divided by 6 without any labels. To get this in lowest terms, I'm going to divide 18 and 6 by 6. And that's because I know that 6 goes into 18 and into 6. 18 divided by 6 gives me 3. 6 divided by 6 gives me 1. So that means that there are 3 girls to 1 boy. Number 2, tell whether the following ratios form a proportion. So we have 8/24 equals to 5/18. Well, you can do this in multiple ways. I'm going to take this 8/24 and I'm going to simplify that down and divide numerator and denominator both by 8. 8 divided by 8 is 1. 24 divided by 8 is 3. Then I'm going to take 5/18 and I'm going to reduce that down, which I can't reduce it down at all because 5 does not go into 18. So you could divide it by 1, but that's not needed. So that one is just going to be 5/18. So those do not equal each other. So 1/3 does not equal 5/18. Another way you could have tried this problem is taking 8/24 equals 5/18 and cross multiplying by doing 8 times 18 and 5 times 24. 8 times 18 becomes 144. Then 5 times 24 becomes 120. Those do not equal each other, so do they form a proportion? No. All right, so number 3. What is the unit rate of 48 rotations in 6 minutes? So I'm going to make this as a ratio of 48 rotations in 6 minutes. Well, just like I did with the first problem, I'm just going to take out the descriptors and just have the numbers of 48 divided by 6. Well, a unit rate means that I have to have a denominator of a 1. So that means that to get from 6 to 1, I have to divide by 6. And whatever I do the denominator, I have to do the numerator. So 48 divided by 6 gives me 8. So when I put my when I put my descriptors back in, that means it's 8 rotations per 1 minute. You could have your answer as a ratio, or you could have 8 rotations per 1 minute. Number 4, solve the following proportion for x. 2/3 equals x divided by 11. Now, certain problems will make it easy to where you can take a number and multiply it by 3 to get to 11. Well, 3 doesn't go into 11 easily, so that's when I'm going to use my cross products. I'm going to do 2 times 11, and then x times 3. 2 times 11 equals 3 times x. 2 times 11 is 22, which equals 3x. Then I'm going to go and I'm going to divide both sides by 3. 22 divided by 3. 3 cannot go into 2, but 3 can go into 22 6 times. So, I'm sorry, not 6 times, 7 times. 3 times 7 is 21. 22 minus 21 is 1. So that leaves me with 7 and 1/3. So x equals 7 and 1/3. Number 5. An airplane travels 2016 miles in 4 hours at a constant rate. So 2016 miles for 4 hours. Complete the table to show the mileage for 2, 8, and 12 hours. Well, for hours, if I have 4 in the second, and technically the third column, then I'm going to put 2 in the second column. Then comes 4, then 8, and lastly 12. So when I solve this, to get from 4 to 2, I'm going to divide by 2. So that means I'm going to take 2016, I'm going to divide that by 2. I'm going to show that work off to the side. 2016 divided by 2. 2 goes into 2 once, minus 2. Bring down the 0. Well, 2 can't go into 0, so that's 0. Bring down the 1. 2 can't go into 1, so that's 0. Then I bring down the 6. 2 can go into 16 8 times. Subtract 16. Nothing left over. So that means I have 1,008. So in 2 miles, they travel 1,008 miles. Well, to get from 4 to 8, I'm going to multiply by 2. So that means I'm going to take 2016 and multiply it by 2. So I'm going to show my work above. 2016 times 2. That's 12, 3, 0, and 4. So 4,032. Great. Well, for this next part, to get from 4 to 12, I'm going to multiply that by 3. That's what I find to be the easiest. There are multiple ways to approach this, but that's the one that I'm going to use. So I'm going to take 2016, and I'm going to multiply it by 3. That gives me 18, carry the 1, that's 4, 0, and 6. So 6,048. So going on to number 6, what is the unit rate? Well, if I had 2016 miles per 4 hours, I want to know how many miles in 1 hour. So I divide the denominator by 4. I divide the numerator by 4. 2016 divided by 4. I'm going to show that work again to the side. Yes, you could be using a calculator. That is fine. I do like to show my work when I can. 4 can't go into 1, so it's 0. 4, that would be 6. 4 can go into 16 4 times. Minus 16, that's 0. So that means that it is 504 miles per hour. Or you could have written it as 504 miles, mph, miles per hour. Number 7. Felicity goes to the store to buy her favorite shampoo. She can buy a 15-ounce bottle for $2.79 or a 20-ounce bottle for $3.19. Find the unit rate for each bottle. Which bottle costs less per ounce and show why? Well, for both of these ratios, I'm going to do dollars per ounce. So the first bottle is $2.79 per 15 ounces. Well, to get the unit rate of 1 ounce, to get from 15 to 1, I need to divide by 15. So that means I need to divide the numerator by 15. This gives me 0 and 186 thousandths, which that actually is going to be approximately 19 cents per ounce. We want to round to the nearest penny, which is the hundredth, the second decimal, because that's how we deal with money. All right, now we want to find how much an ounce for the 20 ounces. So I take $3.19 and divide it by 20 ounces. Well, let me rewrite that. So $3.19 divided by 20 ounces. So I have been using my calculator for this one. And the reason why I'm dividing by 20 ounces is because to get from 20 to 1, you divide by 20. Whatever you do to the denominator, you do to the numerator, which gives me 0.15952. 10 thousandths, which is approximately 16 cents per ounce. Oops. Putting that label of per ounce. So to answer the question, which bottle costs less per ounce and show why? Well, it's going to be the second bottle. Let me rewrite this with a pen. The second bottle, because it is less per ounce. All right, number 8. On a bicycle, you can travel 20 miles in 4.5 hours. What is the distance you can travel in 1 hour? Well, let's put the ratio of 20 miles in 4.5 hours. It wants to know for 1 hour. So I'm going to divide the numerator and the denominator by 4.5. Which is going to give me 4 and 4/10 repeating. So that's about 4 and 4/10 miles. Number 9, how much time would it take you to travel 1 mile? Well, if 20 miles takes me 4.5 hours, I want to know how much 1 mile would be. So I would divide the numerator and the denominator by 20. That would leave me with 0.225. So 23 hundredths of an hour. You could multiply that by 60, and that would give you 13.5 minutes. The reason why I'm multiplying by 60 is because there's 60 minutes in an hour. All right, so we're going to compute the unit rate for each. Jeff and Kyle are practicing for an upcoming cross-country meet. A lap around the track is half a mile around. Jeff ran 5 laps in 30 minutes. Kyle ran 10 laps in 60 minutes. All right. So let's first start with Jeff. 5 laps is equivalent to 2.5 miles. Now the way I had that was 5 representing the laps times half a mile for each lap, which is 2.5. Then for Kyle, he ran 10 laps, which is equivalent to 5 miles. Again, to show that work, 10 times 0 and 5/10 equals 5. Because again, 10 laps at half a mile per lap equals 5 miles. So Jeff ran 2.5 miles in 30 minutes. Kyle ran 5 miles in 60 minutes. So I'm going to add that in for both of them. Number 10, how many minutes does it take Jeff to run 1 mile? Well, if we have 2.5 miles for 30 minutes, I just want to know for 1 mile. So I'm going to divide my numerator and denominator by 2.5. So 30 divided by 2 and 5/10 is 12 minutes. So it takes Jeff 12 minutes to run 1 mile. For number 11, how many minutes does it take for Kyle to run a mile? Well, just like we did with Jeff, I'm going to put my information of 5 miles per 60 minutes. I want to know for 1 mile, so I'm going to divide the numerator by 5 and then the denominator by 5, which gives me 12 minutes. Number 12, how far does Jeff run in 1 hour? Well, going back up, Jeff runs 2.5 miles in 30 minutes. We want to know in 1 hour. Well, 1 hour is equal to 60 minutes. So to get from 30 to 60, I multiply by 2. To get from 2.5, I'm sorry, if I multiply the denominator by 2, do the same thing to the numerator. 2.5 times 2 is 5 miles. Number 13, how far does Kyle run in 1 hour? Well, he had 5 miles in, 60 minutes. Well, I happen to know that 1 hour is 60 minutes, so there's no other calculation I need to do. It's 5 miles. So number 14, who's running faster? Explain your reasoning. Well, if Jeff runs 5 miles in an hour and Kyle runs 5 miles in an hour, they are both running the same speed, so neither are running faster. Number 15, does this table show a constant proportionality? If not, explain why. If yes, state what the constant of proportionality is. All right, to go from 4 to 5, 5 to 6, 6 to 7, each time I go in and I add 1. To get from 30 to 37 and a half, I add 7 and a half. 37 and a half to 45, I add 7 and a half. 45 to 54 and a half, I add 7 and a half. So yes, there is a constant of proportionality. You may have abbreviated as COP. And then your constant of proportionality is 7.5 divided by 1, or $7.50 per hour. Number 16 and 17, the directions say circle whether the relationship between each pair of quantities is proportional or not proportional. Show your work to justify the answer. So I'm going to go in and find my rate of change for each of these. So the first, I'm adding 3 3/10. The second one, I am adding 1 5/10. Then I'm adding 2 1/10. I'm not even going to bother with the perimeter of the square, because if I see that the side length of the squares is not increasing by the same amount every time, that means that it is not proportional. All right, number 17, the side length of cube in inches. Well, I'm going to add 2.5. I'm going to add 2. I'm going to add 2.5. Well, again, this I can tell is not going to be a constant proportionality because, or it's not proportional because my values are not increasing by the same amount. Number 18. The graph shows the cost to rent a jet ski from 2 different stores. Graph each relationship. So the price at each store at the hours of 0, 1, 2, and 3, Water Fun and Super Ski. Well, I'm going to label my axes. My x-axis is in time, H. Then my y-axis is going to be in dollars. I'm going to say cost in dollars. Let's begin by drawing Water Fun. So I'm going to use color differentiation. I'm going to plot the point 0, 0, 120, 240, And lastly, 360. And then I'm going to connect my line. Or I'm going to connect my points with a line. All right, next, I'm going to go ahead and draw a line, plot superski, which is at 0, 20, 135, 250, 365, and then I'm going to connect those points. Number 19, identify which situation is proportional. Justify justify your response. So it is going to be the water fun, and I guess I should have also gone back and shown that my pink graph was the super ski. So identify which situation is proportional. Water fun is proportional. Proportional because it passes through the origin and is a straight line. Number 20, for the situation that's proportional, circle the ordered pair that represents the unit rate on the graph. Well, that is going to be the ordered pair of unit rate. My apologies. That means that you want to have an x value of 1, so that is going to be 1, 20. All right. Carly's class built some solar-powered robots. They raced the robots in the parking lot of the school. The graphs are all line segments that show the distance in meters that each of the 3 robots traveled after seconds. X-axis is time in seconds, y-axis is the distance in meters. So number 21, each graph has a point labeled. What do the points represent? That represents, and this is just one way that you could have answered it, the distance a robot travels in seconds. Number 22. Carly said that the ratio between the number of seconds each robot travels and the number of meters it has traveled is constant. Is she correct? Yes, because all of the points Yes, because all of the ratios create straight lines. All right, last problem. All right, last problem. Number 23. How fast is each robot traveling? How can you compute the speed from the graph? Plot the ordered pair that represents the unit rate for each robot on the graph and write the ordered pair below. All right, so for robot A, we have 1, 5. So that means that's going to be 5 divided by 1. So that means that it is going to be 5 meters per 1 second. For robot B, we have 9 divided by 6, meaning that could be reduced down by dividing by 3, and that's 3 halves. So that's 3 meters per 2 seconds. Then robot C is 5, 2. So you can write the ratio is 2 divided by 5. So that is 2 meters per 5 seconds. The next part is find the unit rate for each robot. Well, for robot A, we've already solved it. It happened to give us this because it's 5 meters per 1 second. Now for robot B, if we have 3 halves, let me change my color actually. If we have 3 halves, I want a denominator of a 1. So I'm going to divide the numerator and denominator by 2. 3 halves divided by 2 is 1 and 5/10. So that's 1.5 meters per 1 second. Then for robot C, 2/5, we want to have a denominator of a 1. So I'm going to divide the denominator by 5, which means I'm going to divide the numerator by 5, which gives me 4/10. So that is 4/10 of a meter per second.